Welcome to this video lecture on estimating a difference between means or proportions. We'll begin with means. Now, when we're comparing means, it's always best to use paired data. For example, suppose we want to estimate the difference between the prices in one retail outlet compared to another. We should compare using the same items rather than taking a random sample of merchandise from one outlet and a different random sample from the other outlet, which could give rise to different types of items. And so we're not comparing like with like. So when it's possible, use paired data. So even though it's a random sample, when you go to the second population, it's not an independent random sample, it's a sample of the same items again. There is a one-to-one correspondence between the items in sample 1 and sample 2. So our problem involves comparing the prices in two greengrocers, Max's and Ben's. And so here we have a randomly selected set of items and the price of those items in each of these greengrocers. So on the first row we have pears. There's a price at Max's and a price at Ben's. So notice that price of the pears at Ben's, 135 cents, relates in particular to the price of pears at Max's. It's not compared with the prices of other items at Max's. So we summarize these data by calculating the differences. How much more expensive is one greengrocer's compared to the other? So we calculate these differences and we always calculate them in the same direction. So in this case, we'll go Max's price minus Ben's price. We need to make all the comparisons in the same direction rather than switching back and forth. So here are the differences: minus 16, minus 16, plus 8, minus 34, minus 30, minus 16, minus 16. You could have made the comparison the other way around and then you would have plus 16, but you would need to have a consistent approach throughout and be clear on what it is you have done. Now, these are the numbers that interest us. So even though it looked like two sets of data, it's really just one set of data that interests us. And those data are the differences. So we now work with these differences and we construct a 95% confidence interval for the mean difference. So this is actually estimating the mean of a population. It's a confidence interval for the mean of a population rather than two populations as such. So the mean difference is minus 17.14 with the standard deviation 13.46. N is 7 because there are 7 items in the sample. And we go to the t-tables as explained in section 4b, and we look up the appropriate value of t with 7 minus 1, that is 6 degrees of freedom, in order to construct a two-sided 95% confidence interval. We get the number 2.447 from the tables. We substitute these numbers into the formula, and we get minus 17.14 plus or minus the error of estimate, just 12.45. That gives us the lower figure of minus 29.59 and the upper figure of minus 4.69. Notice that both of these numbers are negative, which means 0 is not included in the interval. Therefore, we are sure that the average price is not the same in these two outlets. So we can state with 95% confidence that Max's is between 4.69 and 29.59 cents less expensive than Ben's per item on average. We're now going to look at the case where it's not possible to pair the data. Where paired data are unavailable, then we have to take independent samples. Sometimes this is the case. Shortly, we're going to look at an example where we're comparing the prices of apartment rentals in Lucan with the prices of apartment rentals in Naas. Well, now, it's not possible to have a rental for an apartment in Lucan and have the same apartment in Naas. That's just not possible. So we will simply have to take a random sample of apartments in Lucan and take a random sample of apartments in Naas, and those will be independent samples. We have this formula for making the comparison. So the difference is mu1 minus mu2 is what we want to estimate, and that's estimated by x1 bar minus x2 bar. The difference between the sample means is, of course, the point estimate of the difference between the population means. Plus or minus, for the error of estimate, we use t with an appropriate number of degrees of freedom and the standard error of the estimate, which we will present to you now shortly. So there's the problem we're solving, apartments in Lucan and in Naas. We want to estimate the mean difference in monthly rents. based on those figures. The sample sizes in this case aren't equal, and it's not necessary that they be equal. So we have 4 apartments randomly selected from Lucan and 5 from Naas, and we want to estimate what is the mean difference in rental between these two towns. So the first thing we do is we assume that the standard deviation is the same for both populations. So we use formula 4.9 to estimate the assumed equal standard deviation. So we take the quantities from the samples and substitute into that S squared formula. So we get an estimate of the variance. And then we use formula 411 to estimate the mean difference. The degrees of freedom is 7, 5 plus 4 minus 1 minus 1. Looking up the t tables, we get t is 2.365, and then we substitute the numbers into the formula using in each case the common variance estimate. 1057.23 is used in this formula. It's what we believe to be the common variance for apartment rental prices in Lucan and also in Naas. Our estimate is 35.75 plus or minus 51.58. Applying the minus, we get the lower figure of minus 15.83, and the upper figure is 87.33. Notice that that interval does contain 0, so it's possible that there is no difference. But we can state with 95% confidence that Lucan is between €15.83 less expensive and 87.33 more expensive than Naas for apartment rental on average. We now move on to differences between proportions. Now this formula is used for estimating proportions in 2 distinct populations. For example, you might want to estimate the difference between the proportion of Wicklow voters who support the Labour Party and the proportion of Mayo voters who support the Labour Party. Those are 2 distinct populations. You would not use this formula to estimate the difference between the proportion of Wicklow voters who support the Labour Party and the proportion of Wicklow voters who support the Green Party, because those are not distinct populations. So, the example we will look at is we've got Liffey Valley shoppers in that shopping outlet, and we've got Blanchardstown Shopping Centre shoppers. We're interested to know if the proportion of shoppers who purchase clothing is different in those 2 shopping centres, and how different is it? So we want to construct a 95% confidence interval for the difference between the population proportions. So there we have our 2 samples, and each sample gives us a point estimate. In the first case, 0.49, 49%. In the second case, just 0.1133, 11.33%. We substitute these numbers into the formula, which contains the 1.96 to provide 95% confidence. And we get 0.3767 as the point estimate, so we think it's a 37% difference, with an error of estimate of 7.8%. Applying the minus, we get 0.2987, 29.87%, and applying the plus, we get 0.4547, 45.47%. So we are 95% confident that between 29.87% and 45.47% more shoppers purchase clothing in Liffey Valley Shopping Centre compared to Blanchardstown Shopping Centre. You can read more about this in the textbook in section 4E.